Physics students, good afternoon. Mr. Fugit here. In our video today, we're going to be looking at some problems involving the ideas of energy and energy conservation. Specifically, we'll be looking at questions number 1 and 2 on the review for test number 5, which covers over the ideas of work, energy, and power. The problems we'll be looking at are available on Canvas. There's also a key for each of those problems on Canvas if you're wanting to work and check some of your values with what we do here. So here we'll be looking at problem number 1 for our review on test 5. Problem number 1 says this: a roller coaster has an initial hill 25 meters tall. A chain pulls the cars to the top of this hill. How much work has the chain done to raise a car with a mass of 600 kilograms to the top of this hill? So we've got something like a hill here, and we're asked to find out how much work is done to raise the car up this 25 meters. So to find the work done on an object, we can look at, well, really two things: a force, a displacement, and an angle between the force and the displacement, or a change in energy. Now here, I'm probably going to look at a change in energy because we're not really told anything about a force directly, but we are told some things about heights, which means we might be able to find something along the lines of gravitational potential energy. So here this would be equal to our change in energy, which would be E final minus E initial. Now, our initial point would just be down here on the ground, and our final point would be up here at the top of the hill. Initially, I'm probably going to assume that my energy would be 0 initially, because we are at rest on the ground, and we're not told anything about a spring here. And then our final point, it says we can assume we're stopping at the top of the hill, so energy final here would really all be gravitational potential energy. And we can find that value, gravitational potential energy, mgh, where the mass here we're told is 600 kilograms. Gravitational acceleration for the Earth, 9.81 meters per second squared. And our height is 25 meters. So now I'll plug those values in. 600 multiplied by 9.81 multiplied by 25, I get 147,150 joules. That would be equal to my energy final. And remember, the work done is equal to our final minus our initial energies. If our initial energy is 0, well, to kind of put all this together, the work done would equal to the change in energy, E final minus E initial. E final is 147,150 joules minus 0, so our work done would simply be 147,150 joules. We start with no energy, we end with a lot of gravitational potential energy. We can compare what we start with and what we end with to find our change in energy, which would be equal to our work done. Now, question number 2 says this: how fast will the car from number 1 be going when it reaches the bottom of the first hill, ignoring friction and air resistance? Assume the bottom of the hill is 25 meters below the top point. So now we're looking at what's going on once we come back down. And if we are ignoring air resistance and ignoring friction, we can probably assume that our energy is going to be conserved here because there are no forces that are going to take the energy of our object away. So now this point here is going to become the initial point for this context, and this point over here at the bottom of the hill would be our final point. Again, remember, initial and final are just terms that we use to describe two different points in time. So initially we have, well, 147,150 joules of energy, and we're going to set that equal to the energy we have final. So this is scenario number 2. We're going to set our energy initial equal to our energy final. Initially, we calculated that our object has 140. Sorry, the board seem to be a little bit sensitive here, so I apologize for any extra markings. 147,150 joules is equal to our energy final, which, if we think about what types of energies we would have there, our object would be on the ground, so no gravitational potential energy. There are no springs involved here, so no spring potential energy. So really our energy final is all going to be kinetic energy, which would be equivalent to 1/2 mv squared. So I'm going to take my value for energy initial and use that to find my velocity. So 147,150 joules is equal to 1/2 multiplied by 600 kilograms multiplied by velocity squared. I could quickly show that 1/2 multiplied by 600 would give me a value of 300 kilograms. And then I could divide by 300 kilograms on both sides of our equation. So I would get something about 147,150 divided by 300. So I would get a value of about 490.5 is equal to v squared. And then I would take a square root of that value to get about 22.14 meters per second. So that would be somewhere in the neighborhood of about 55-ish miles an hour for our velocity. So here in really part one, we're looking at the ideas of changes in energy, work being done to change the energy of our object. And in part two, we're looking at an energy conservation scenario. Assuming that we have no outside forces on our object, that would be taking our energy away. So ignoring things like air resistance and friction, we can assume energy is conserved in part two. So hopefully that gets you started on questions 1 and 2 on the review for test number 5. As always, if you have questions, you're welcome to ask. Direct them to me, as well as access the resources available to you on campus.